Okay, question here on number 2 in section 6.2, which you'll notice right away we're dealing with volume of a cone. And when we set those problems up in class, I always had you do those cones kind of horizontally like this here, guys, where you would see it like that, and your axis would kind of be going right down the middle right here. They've got it going a different direction, and you're going to end up with the same answer, whether you do it their way right here or my way up here. But I want to try to go ahead and explain how to do it in the way that they discuss it, where we're kind of moving vertically here rather than horizontally. So let's ignore number 3 for right now. So let V be the volume of a right circular cone of a height of 10, got it right there, whose base is a circle with a radius of 4. So they break this down for you into 2 parts right here. Basically, they're telling you in part A to try to find your area formula, which is always the hard part of volumes, and then B is what we would normally do here, where we integrate that area formula. So what we need to work on A is trying to come up with a formula here for area of our cross sections. So what I'm hoping you guys can see is that in this cone, and by the way, we ignore this word a lot, but this will become important later on in this chapter, in this section of homework, we're dealing with circular cones here, which means that not only is the entire base a circle, but anywhere you slice this thing along that vertical axis, you're going to end up with circular cross sections everywhere along the way. So what we're trying to do is come up with the formula for the area of one of those circles. So we start with something really simple, guys. We know that every circle is pi times our radius squared. But what we need to do now is try to express that area function in terms of whatever variable it is that we are going to integrate with respect to. And since this thing is running vertically now, I think that y is probably what we're going to use for the height of our pyramid, and that tells me that we're going to run this integral here with respect to y. So we need to try to come up with a way of expressing the radius of each one of these circular cross sections right here as a function of y. Now, as you'll notice, each of those 4 radii that I just drew in red are a different length. That means that r is not going to be constant, but it's a variable expression. Now, what I'm about to show you here, guys, is not something you're going to have to do for me on a quiz or a test. You're not going to have to do it on the AP test, at least I've never seen it asked before. But we need to try to come up with a way of figuring out what r is in terms of y. So I'm going to make a quick little table right here, guys, that if y is a particular value, what do we see for r? Let's show you what I mean here. Right here at this spot, guys, the height of that circle right there is 0. And when our y-coordinate is 0, the radius of that circle there formed is 4. Let me jump down here and say, okay, if we were to go all the way to the top of this cone right here, when y, your height, is equal to 10, how big is your radius there? Well, we don't even have a circle. The radius there is 0. And I think it stands to reason then, guys, that if we went halfway up on this thing right here, from the height from 0 to 10, that would be 5, that our radius would be halfway between the 4 on the bottom and the 0 up on the top, and our radius would be 2. So my question for you guys is, how do we take this little table of values here and try to come up with an expression that tells us r in terms of y? Well, here's the way I would do that. I would focus on how big this thing is at its maximum, a radius of 4 with a height of 10. And I just kind of make a ratio out of that. Radius to height is 4 to 10, which of course simplifies to 2/5. So I'd be really tempted to say that r is 2/5 y. And if we were doing the problem this way, guys, where the cone or the pyramid got bigger the further the height moved along, that's how we would do it. But if you plug a 0 in for y right there, that does not get you the 4 that we're looking for. You can see almost right away that that doesn't work. The kicker here, guys, is that the bigger that y gets, r gets smaller. And so, as I said, this is not something you're going to have to do a ton of, but here's how you do it, guys. We're going to multiply that 2/5 times the quantity of the full height, which is 10, and then minus y. And by making that a minus y, that's going to create the inverse relationship that we were looking for. Let's test it. When y is 0, do we get a radius of 4? Well, 10 minus 0 is 10, and 2/5 of 10 is 4. Check. When y is 5, we should get 2. 10 minus 5 is 5, and 2/5 of 5 is 2. So that one works. And when y is 10, we should get 0. Well, yeah, 10 minus 10 is 0 times 2/5. There you go. So what we just came up with right here, guys, is a formula here for r in terms of y. And now that I've written that, I don't like where I have all this. So let me move this blue statement down right here. And now that we know this, let's bring it down here and try to find an a of y formula here. That area formula is still pi r squared, but we're going to replace the r now with 2/5. Probably should have made that a bracket. 2/5 times the quantity 10 minus y. Close the parentheses, close the bracket. That's r, and we still need to square that. And I think we could probably simplify that just a little bit and make that a of y is equal to. Now, this is, guys, a big monomial right here, which means each factor, the 2/5 and the 10 minus y, each one of them gets squared. So I'm going to square the 2/5 to make that 4/25 and multiply that by the pi. So I'm going to get a coefficient now of 4 pi over 25. Then the binomial, 10 minus y, that's going to get squared as well, and that is my a of y formula. So that is the answer right there, guys, to part A, where they just wanted us to come up with a area formula here for our horizontal cross sections. And now, as we move on to part B, we're going to go ahead and do what we would normally do here. Let me switch colors. Let's go purple here. And again, the hard part of every volume problem is coming up with this a of y formula. The rest of this should be pretty easy. So volume is going to be an integral. We're going to do all of this with respect to y of this a of y formula. So I'm going to pull the coefficient 4 pi over 25, because that's all a constant, out in front. And the integrand then is just going to be 10 minus y quantity squared. And all that's missing now are the limits of integration, the lowest and highest values of y. Well, this cone began at a height of 0 and it terminates at a height of 10. So that's where we're at here, right, guys? And I don't think this integral would be too bad to do by hand. I might regret this, but I'm going to try it here. So 4/25. And then what's going on here, guys? We have a linear binomial to the second power. So my antiderivative is going to be the same base, 10 minus y, raised to a higher power now, 3, and we divide by that new exponent. So that'll put a 1/3 out in front. But also, we need to divide by the derivative within. And because that derivative within is just a constant, we can do that. That derivative would be a -1, so that's just going to put a negative out in front of this whole thing. And this is all getting evaluated from 0 to 10. Now, you might be a little concerned about the fact that I just put a negative out in front of this whole thing. That kind of suggests that the answer is going to be negative, but I have a feeling this is going to work out okay. All right, nothing really simplifies out in front, so this is still a -4 pi over 75, but now in brackets here, I'm going to put the 10 in first. So the 10 minus 10 is going to be 0, and that gets cubed, and then minus, we put the 0 in there now, and 10 minus 0 is going to be 10. And that gets cubed. So I think maybe you can see that my quantity inside the brackets is about to end up negative, which will multiply by this negative, and everything will be right in the world, I hope. So 4 pi over 75, actually negative, now gets multiplied by that 0 minus 1,000, so -1,000 here. And the negative times a negative is going to be a positive. Now, what can I do? I could divide out a 25 from both of these numbers. 25 goes into 75 3 times, and 25 goes into 1,000 40 times. I don't know that it's going to get any cleaner than that. 40 times 4 is going to be 160. There's a pi up there, and that's all going to get divided by 3. The negative times negative is positive, so I feel pretty good about that answer. But, of course, what kind of geometry teacher would I be if I didn't also check this problem geometrically? Formula for volume of a cone is 1/3. The area of its base is pi r squared because it's a circle times h. So this cone is 1/3 pi. We had a radius of our base of 4. That's going to get squared squared, and the height of this whole thing was 10. So 4 squared is going to be 16. 16 times 10 is going to be 160. Oh, we'd multiply that by a pi and divide all that by the 3. That doesn't simplify at all. So we got the same answer using both calculus and geometry, which makes me feel pretty confident about my answer. And of course, because it was a volume problem, I should put cubic units on there, but there we go. So that looks like our final answer then, guys. Ooh, let's look at it all together there for problem number 2 in 6.2. Now, just to reiterate, I'm not going to ask you guys on a quiz or a test to do a cone or a pyramid this way. I kind of like these problems a little bit better, but this was just to get you guys some exposure for how to deal with a problem that's set up that way. So that's number 2.